Welcome back to the arcade. Today we're going to do something a little different. We're going to continue on video I did a few months back, a couple months I think, something like that, where I unboxed my Logic Comparator, Hewlett Packard 10529A Logic Comparator. And at the time I thought it was probably working, but I wasn't 100% sure, and I didn't have a test card to test it. That was my main problem. But I did what I could do. I took it apart, and I checked. I had a suspicion one or two of the LEDs were bad. This has LEDs for each pin of the IC chip. I know it's kind of hard to see, but because this one has the smoked plexi, but in here you got LEDs that for each one of the pins on the LED that light up and tell you, whether the chip you're testing is good or not. So plus it didn't have any of the insulation on the wires that goes to the clip. Well, as you can see, I found a solution for it. Might not be a perfect solution, but I think it's good enough. This stuff right here is called spiral wrap, and it's a flat plastic that's spiraled into like a spring, and it's very flexible. So I got me some off of eBay. It's really cheap. Matter of fact, I had to buy a 10-foot section of it, and as you can see, it's flat and it's in like a spring, and you just wrap it around the wire you want to insulate. And then I went ahead and put some zip ties on each end where the strain relief is, and I think it's going to work out good. So that problem was solved. Now, I suspected some of these LEDs were bad, so I took this apart. I didn't do it on camera, so I saved you from that. And I tested each one of the LEDs with my multimeter. And easy way you can test with a multimeter, an LED or a light emitting diode. And here's one of them right here. This is the same type that I used to replace them with. You put your meter on diode test, and you just hook the leads up to it, and it'll light up if it's good. Plus it'll give you the voltage drop, which in this case is 1.631. So that's how I checked them. I checked them in circuit, and it worked fine. So I found 3 of the LEDs that were bad, so I replaced those. So now I think I got it to where it works, but I don't know for sure because I don't have the test card. Now, from my last video, I had 3 people, 2 on CLOV, the Killer List of Video Games message board, and 1 on the message on my video on YouTube, which he could be a CLOV member too, I'm not sure. But all 3 of them offered to send me their test card very graciously so I could test my comparator to see if it was working. And I thought about it, and I started to take one of them up on it. But I wrote them all back and said, I appreciate the offer. I might still take you up on it, but I'm going to try to find one. So I put out a one ad on CLOV and on Facebook, and I waited and I waited and I refreshed it, and nobody came back with a response. I guess nobody had one they wanted to sell. And that's understandable, because if you have one of these and you only have one, you're not going to want to sell it because you need it to test it. And usually, I guess they just get lost in the shuffle. These people don't know what these are, and they get split up. And You know, you find a lot of these kits on eBay where they're missing the logic probe or the logic monitor or the pulsar. So, you know, I guess sooner or later you're bound to find one that doesn't have the test card. So, okay, I thought about it for a while and I said, well, let me look at the schematics, and they have the schematics in the manual of the test card. So I went ahead and printed them out. And I said, well, there's not very many components there. How hard could it be to build? Thought about making one. If you can't find it, make it. Okay, so what do we got? We got 3 transistors, a couple capacitors, a handful of resistors, 2 IC circuits. This is actually one, and up here is another one. You know how they draw them on a schematic. They don't draw them on a schematic, you know, like they physically are. They chop them up into sections. But okay, so I thought, well, yeah, maybe I can do this. So I decided to get a, you know, how would I integrate this? How would I build it? Well, nothing says it has to be like the original, which basically goes in here. And the original one, I'm pretty sure, well, I know for a fact, this is the universal card where you put the IC you want to test in here, you set the dip switches, and you put it in the unit, and it's the universal comparator card. So I said, well, yeah, that's the size of it, so I could make something that size. But then how would I make the connection on this end, you know, where it plugs into the unit? So I said, well, let me just use one of these little comparator cards, and I can run a ribbon cable from here, and I could put the components on an experimental breadboard, build it on here, run a ribbon cable from here to the card, and then put the card in the unit. All right, well, that was my first thought. So I went ahead and ordered all the parts. Okay, I went through the parts list. I figured out what the 2 ICs were. I had to do a little detective work because they give the HP numbers, so I had to, some of them I had to look up the HP number and find the list, which is a PDF file which has HP numbers, and then beside the HP number it tells you what the equivalent is in a standard part. So I was able to locate all the parts and get them in. So then I got to thinking, I said, well, what if I could make it in this form factor so it can all go in the unit? So I took one of these cards right here, and I took this right here, and I cut the end off of here, and I cut this, and I made this the same shape as that, and I came up with this. Okay, this is the same shape as this, and it fits in the unit, and that would work out fine. So then I got to, I said, well, let me see if I can put the components on here and get them all connected up according to the schematic. Well, then I made a blow up of it right here, and then I started tracing out the you know, where everything was going to go, and then I realized that that's just not going to work. I mean, you could make it work, but you would have to put all kinds of, the traces would just look terrible. You'd have to put wires going everywhere, and I said, that's not an option. I gave up on that. Okay. So I went ahead and I said, well, let me see if this thing will work. So I took the basic, the heart of this unit is this right here, Q1, which if you look at it, it doesn't look like a standard transistor. This is a PNP transistor, and this is an NPN transistor. Okay. Well, what the heck is this? This is a little bit different shape. So I got researching it and found out that this is a UJT, unit junction transistor, a 2N2646. Okay. What a unit junction transistor is, it's different than a standard transistor, but this is acting as an oscillator. In more modern stuff, you would use a 555 timer IC to make this type of a circuit. But back in this time period, in the 70s, I believe this was designed back in the 70s. Well, it might have been early 60s, but this unit right here was in the 70s. This was a common thing back then for making an oscillator. So this is the heart of it. So I said, well, and you make what you call a relaxation oscillator. And there's all kinds of videos on YouTube about how to make one. But basically, it's the same circuit. You got your unit junction transistor. You got a resistor here, and a capacitor here, and another resistor here tied to ground. And then you got your power source from ground to up here. This has an emitter, a base 2 and a base 1. So it doesn't have a emitter and a collector. It's just got an emitter, a B1, base 1, and a base 2. So I said, okay, let's build one and experiment with it. So that's what I did. I just put it on one of these little breadboards, and this was using the exact components from the schematic. Okay, now I had to add the LED for visual reference to see if it was oscillating, because I tried to use my scope and I really couldn't get anything out of it. I don't know why, but this scope works good for a monitor, for a vector monitor for testing vector boards, but I haven't been able to use it in this project. It's got problems, okay? So, or maybe I just don't know how to use it. But anyway, so I did this way to find out if the transistor was working. Now, I ordered 2 of these unit junction transistors. They're kind of hard to find, and they're kind of pricey. Well, not bad, but they're like $5 a piece. Okay, so I got 2, was supposed to have been 2 new old stock, and they are Motorola's, which the original one used a Motorola. I soon found out that it's a big difference in these. I ordered some more, which is more modern, I guess, made version of it, which they still call it 2N2646, but it's different. If you substitute it in this circuit, then you have to change the values of the resistors and the capacitor in order to get the frequency that you want. And even this new old stock one is different than an original. So it's a lot of variations in this circuit. So anyway, let me set this up real quick and just show you what it does. Okay, I got the power hooked to it. I'm running 5 volts, which is what the original unit is going to use when you put it in here. And as you can see, the LED is flashing. So it is working as an oscillator. So I said, okay, well that is going to work. So that's when I tried to, I went ahead and put the resistor in here in place of the light emitting diode, so it would be more like the original circuit here. I put a 200 ohm, which is R3 here, and I tried to use my scope here. I couldn't get nothing, okay? It wasn't oscillating. Now, when I hooked it up to the scope with the LED on here, I could see it was pulsing, but it didn't give me the waveform that I was expecting. Like I say again, I think it's the scope itself, okay? So I got to thinking, I said, I need a way to see the waveform. I need a better scope, okay? But I don't want to spend a bunch of money. So I got looking at some YouTube videos of demonstrations of this very circuit right here. There are a bunch of them on YouTube, so if you want to know more about a unijunction transistor, look it up on YouTube, and there's all kinds of videos on it. Gives you the demonstrations, shows you the waveforms, blah, 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 all that stuff. So, let me show you what it did. Hang on, let me set it up. Alright, well this is what it did. I bought a little cheap digital scope off of eBay. I seen one of the videos of somebody who had built one of these circuits, and they were using this very scope. So I decided to buy one and try it out. So here it is, and there is a sawtooth waveform, and it's running at just a little over 2 hertz. Okay, so that's within the frequency that the original is running. How do I know this? I'll get to that a little bit later, but at this point I didn't know what frequency the original one runs at. Okay, that was still a mystery, but that's what I'm looking for. And when I took the light emitting diode out and put the resistor in, I was getting nothing. Okay, it wouldn't oscillate. So I said, okay, what's going on here? So as I learned more about the unijunction transistor, I found out that you can vary the frequency by changing the capacitor and the resistor. Get this out the way here. By changing this 10K capacitor right here and this 33 microfarad capacitor, by changing the values, you can change the frequency that it oscillates at. Also, R3, this 200 ohm, you can change that, and that will affect it to a certain extent. Now later on they made a revision of this test board, and they changed R3 from 200 ohms to 51 ohms, I believe is what it is. So later on I changed that to 51 ohms, and that helped. But I found out that the variations in the transistors itself, different ones required different values in order to get it to even work. You can have this 10K resistor right here, you can have it too low and it won't oscillate. You can have it too high and it won't oscillate. You have to get that sweet spot. You have to figure out where it is. And different transistors made at different times, probably made by different manufacturers, all have a different sweet spot. I don't know how else to say it. You know, I'm not an electronic technician guy, so so I just had to experiment and play around with what I had. So I created, I got some more breadboards, experimental breadboards, so it'd make it easier. And I played around with different values, different capacitors, different resistors. different different everything. So then I moved up to this one right here. And this one is actually a complete circuit of this right here minus the ICs. So if you cut it off right here, everything that's right here is right here on this breadboard. So all three of the transistors, all the resistors, and I started the diode, and I started playing around with different values, different value capacitors and everything, so I could figure out how to get it working. And I did. I figured it out. And but anyway, I got to thinking, well, I still need a circuit board. So I still got that problem. You know, I can make the circuit, but I can't use this to test this. So what can I do? So I decided to look at PC board programs, and to make a board. I've never done that before, but I said, how hard can it be? So I went ahead and I found 3 different programs online. I'll put a picture of just what they are up here. One was Eagle. One was, I think they call it KiCad. And the other was, gosh, it escapes me, but that's the one I used. Okay, it's called Easy EDA. That's the program. So I tried all 3 of them, and Eagle, that just seemed too hard. I tried the other one, KiCad. That was a little better, but that still had too much of a learning curve. I'm not much for sitting down and taking a course on how to use the thing. But Easy EDA seemed very easy to me for some reason. So I sit down with it, and first thing you do is you make the schematic. So here's a printout of the schematic that I made. So this is the complete schematic of the test board. Okay. Once you have the schematic, then you convert it over to making the PC board. And probably the hardest part was getting the shape correct. But I figured that out. All I had to do was measure this one and also making the fingers for the pad right here. I had to take and measure these, find out what the spacing was and how far apart they were, and then I had to draw the outline of the board, and then I started by drawing in the pads. Okay, and once I got that, the rest of it was easy. You just transfer the schematic over to it, and then you just start hooking everything together. Okay, so basically I did that. And I sent it in, placed an order, and I placed an order with JLCPCB. Okay, and this is the board that I designed right here, and I based it off of photographs that I took offline of the original board. I'd taken the original board, I blew them up, and I tried to go through the original schematic and try to connect all the points I even found only found one picture of the back side of the board. So I did that, and I tried to make sure that the schematic lined up with an actual board. And I discovered there was some, before I finished this right here, I'm getting ahead of myself. Before I finished that, I discovered that there were some mistakes in the schematic. Okay. First one is rectified in an update to the manual. If you find that online and download it, it'll tell you what the difference is. But I figured it out before I actually seen that. On the schematics, this IC right here, they have it listed as U1. Well, it's not. It's actually U2. And U2 is actually U1. So they had the ICs labeled backwards, which would kind of get you confused because, you know, they're not the same IC. They're different ICs. So you have to make sure you get them in the right position. They're both 16-pin ICs, but, you know, if you put them in backwards, it's not going to work. But I figured it out because of the pinout. I got the pinout of the ICs, and I compared the pinout of that, the pinout to the pinout that's on the schematic, and that's when I discovered, hey, this thing ain't right. Okay. Another thing I found out is up here, these are the fingers on the board. That fingers like are on here. Okay. They just had these labeled backwards. They had this one labeled as B15 and this one labeled as A15. Well, I switched them around. I wrote an A over to B and a B over to A. It was connected correctly. It's just they had it labeled wrong. So if you were going by the label, you could actually get those switched around backwards. So that was mistake number 2 in the schematic. Mistake number 3 was right here. R6, 3000 ohm resistor. They have it terminated right here and say it's plus 5 volt. Well, by looking at the pictures online of a real board, let's see, it was R6. R6 is right here. Well, if you look at the traces and how it's wired up on the board, you'll find that what they say is plus 5 volt actually goes to VCC, which might be the same thing as 5 volts, but why would you, you know, like right here is VCC. This is VCC, okay? This is terminated VCC. This is terminated VCC. All these connect to the VCC, which is this line right here, okay? 5 volts is up here. On the schematic, 5 volts from the terminal where you hook the 5 volts up goes up here, hooks to Q2, the emitter of Q2, and then goes to B1 and A1 on the terminals. It doesn't connect anywhere else. So if this is VCC and this is 5 volt, how can they be both? Because this on the board is tied to the VCC line, but nowhere on the schematic is the 5 volts tied to the VCC line. So I went ahead and I made a judgment call. I said, if it's wrong, once I get the board, I can cut the trace and rework it. So that's what I did. And turns out I was right. This doesn't connect to 5 volts. It connects to the VCC. All right. So I went ahead and ordered the board. I also ordered 30 of these boards right here, which this board was designed by Doug on the Callista Video Games message board. He goes by Doug DB, I believe. Hope I got that right. But Doug uploaded these so that I'll put them on his website so everybody can download this and make their own cards. As long as you don't sell them for profit, you know, he's okay with you downloading the file and making them. So that's what I did. I went ahead and made 30 of them for my own private use. So here they are. So I should have plenty of these blank cards for a while. And I ordered 5 of these. Okay. So here's the finished product. Okay. There's the top side. And there's the bottom side. So now I had a PC board. So now all I had to do is populate it, right? Okay, well, that's what I did. I populated it. And here it is right here. I still had problems with it, and I couldn't figure out the exact values, so I went ahead and I fixed this kind of like a test bed. I put I took SIP strips and I broke them apart and I put them in here to use them as plugs so that I could plug different components in. I put 3 of them here where the unijunction transistor goes so I could change the transistors to go from what was supposed to be new old stock originals and the ones that I got that are clearly more modern equivalents. And also so I could get the change R1, the value of R1 and C1, which is the capacitor here. That way I could fine-tune and get this working, which I did. I fine-tuned it and I got it working. I figured out the values I needed for each one of the different unijunction transistors. I even found the original style, what do you call these, turrets? They call these turrets, where you connect the power up to. So, yeah, I even put them on the board. So anyway, I got it working, and this is the final version I come up with right here. This one, I went ahead and put a, believe it or not, this is a variable potentiometer for R1, which originally is a 10K resistor. Now I could take and measure, once I got this dialed into the right frequency, I could take this and put it in my, use an ohm meter and figure out what value I needed, and I could just put a regular resistor in there. But I found out that it's so, the values, for one thing, are kind of critical, and between the different unijunction transistors, it varies. So you can't just pick one value. I mean, you can, because it doesn't have to be exact. The frequency doesn't have to be exact. But I like to get things as exact as I can. So I opted for the variable potentiometer. Now this one here is a 25 turn pot. Yeah, every time you turn this little brass screw right here is 1 turn. So from one end to the other is 25 turns. So that gives you a pretty good adjustment there. So anyway, I settled on this, and this is my final version. But in the meantime, while all this was going on, this was just kind of a bug. You ever had one of when you started something and you just had to see it through to the end? You had to make it work. Well, this is one of them things, because I didn't have to do this. I didn't have to go this far, because after I had ordered the boards, even before I populated one, guess what happened? I found an original. New old stock still in the bag, okay? So I didn't need this anymore, but it was just nagging on me. All right, you started this thing. Finish it up. Get it to work. You can do it. So I said, okay. All right, let me get this out of the bag. I'll be right back. Okay, well, here they are side by side. As you can see, the component placement is different. And I got a wider area up here where it plugs in, but that's okay. And it's not a one-on-one recreation, obviously. The outline or the size of it is. It fits perfectly into the Logic Comparator. And functionality-wise, it's identical. Okay, it uses all the same components, except it uses a different value for the capacitor here, and it uses a different value for the resistor here. And I went ahead and made the upgrade and put the 51 ohm resistor here, where this one here doesn't have the 51 ohm. This is one of the originals, which still has the 200 ohm in it, okay? Which is okay. I'm not going to change it because this is original and it works. So, since I now have an original, I can hook it up to my little scope and find out what the frequency is supposed to be. Okay, and that's what I did, and that's how I knew what frequency to set my reproduction board. All right, so let me go ahead and set the original one up to the scope, and let me show you what the frequency is. Okay, so I got the original board hooked up to my little scope here, and as you can see, there's the waveform, and there's the frequency up there in the upper left-hand corner, and it is 2. It's flickering a little bit. 2.686 basically. Okay. And that's on the taking the measurement from the emitter of the unijunction transistor, which is between R1 and C1. Okay, that's where I'm measuring this frequency from. Okay, now let me hook up my board and let's compare it. Okay, well, I got my board plugged in. Let's see what we got here. There's the waveform, and we got 2.736. Okay, a little bit off, but ain't no problem. We can tweak that. All right, let me turn it just a little bit. Going the wrong way, down to 2.6. see. What was the frequency again? 2.686 is what or 83. Alright, I went a little over. Okay, that's close enough. You get the picture. It doesn't have to be that critical. It's not a critical measurement. I mean, it would probably work if I was to cut it down to 1 hertz or up to 3 hertz. It would work just fine. But I like to kind of get it in the ballpark. All right, well, here's the big thing. Let's go ahead and put it in the Logic Comparator, and let's finally find out if my comparator works. Okay, I got the original test card in, and it is running. Now you can see the 3 LEDs that are replaced because they're much brighter, but they're all flashing at the same rate. So we are working on 100%. All right, and there's one more test you can do. That's to take the logic clip, and I'm going to unplug this. I need both hands here. Make sure I get the clip on right. All right, this is basically a continuity test to make sure your clip is working. Now this one has one long flash and then a short flash. And as you can see, all the LEDs are lit. So this comparator has passed the self-test. Okay, so now let's disconnect it. We'll take the original card out, and let's put my repo card in. And let's power it up. And let's see what it looks like. Same thing. All of them are flashing about the same rate. All right. Let's put the test clip on. And power it back up. There we have it. A long pulse followed by a short pulse. All the LEDs are lit up. Now, this is one thing I'm debating. Should I replace all those LEDs with the same type LED so that they all are the same brightness, or does it really matter? I can live with it like it is, I guess, but since I had 3 of the originals fail, I guess the rest of the originals are prone to fail, and the camera picks it up brighter than it is in real life. I wish I had one that had the clear plexi. This has got a smoked plexi on it. The newer ones have a clear plexi. I guess that was something that you know, they decided, yeah, they messed up on that. They should have had a clear plexi on top to make it easier to see the LEDs, but I can live with it like it is. Well, there you have it. That's my journey I went through. That's what's been taking up my spare time. I've been going back and forth with trying to get this thing working. And, you know, I've only had like an hour or two every night to work on it. And not every night. So, I mean, like I've been constantly on it. But that's basically the only project that I've been doing because, you know, I had to sit and wait for some parts. I ordered some more resistors because I was trying to get a resistor so I wouldn't have to use the variable resistor here. But it's, I decided to go with that route right there. So yeah, there you have it. I just had to stick with it till I got it done, and I got it done. So, does anybody have a Hewlett Packard Logic Comparator and they don't have a test card? Well, I know somebody that reproduced them. So I only got 5 of them. So I think I'm going to go ahead and just, I got the parts, and I might as well just go and build them all out. Even my test ones, I think I'll go ahead and I'll desolder the sockets I put on there, and go ahead and complete them and have 5 of them. And I really didn't intend on selling these, but if somebody wants one, I mean, we can talk about it. If you can't find an original, they are kind of hard to find. I did make up a price list of what it cost me, so let me find that and I'll be right back. Okay, so I found the price list. I went through all the parts I ordered. I ordered way too many parts. When I work on a project, I usually order extras of everything, and that way, if you know, it kind of adds on to what I have on hand, and you never know when you might need one of the parts that you've ordered. So anyway, looked up the price list, and well, I'll just put the original one here. These little diodes, they're cheap. They're like 0.05 cents each. So 17 of those were 85 cents for the diodes. That's no biggie. The Q1, the unijunction transistor, the 2N2646, a couple of them I paid like $5 a piece for them. Or no, I didn't. I paid like five something for 2 of them. That's what it was. They're basically $2.70 a piece. Okay, so it's $2.70 for that. Q2, which I used a 2N3638 because I couldn't find the. No, I used a 2N3906 because I couldn't find a 2N3638. They were like 11 cents each. Okay, so one of them. Q3, which I use NTE 123A. One lot I bought because I found some actual 2N2369s. One lot was $1.08, and the other one was like $2.08 each. We only need one of those. Then C1 capacitor, 50 cents. This is the high dollar one, the 300 picofarad at 300 volt capacitor, C2, $6. It doesn't matter if you got it from DigiKey or Mauser. Matter of fact, I got some from both. They were $6 each. It only takes one of those. The dummy IC, well, I just put in a regular IC. I don't remember which one I used. It's just some I had on hand. I went ahead and put sockets into. So, but the dummy IC, it doesn't matter what you put in there because all the pins are grounded together. So that's what I did. Then the resistors, R1 was 50 cents. All the resistors were 50 cents. And there's 1, 2, 3, 4, 5, 6, 7 resistors, 50 cents each. This is probably one of the other high dollar parts. U2, which is an SN7473N. Or you can, if you can't find that, you can do the NTE 7473. They're $5.30 each. Takes one of those. U1 is a SN7400N. They're $1.78 each. The Turrent terminals, these terminals right here where you hook your 5 volts and -2, these terminals are $1.20 each. You can, I believe I got those at DigiKey. Mauser had them, but they were out of stock. They're $2, no, they're $1.20 each. So it's $2.40 for 2 of them, for one board. And then the 50K pot, the 50K 25 turn pot is $1.50 a piece. The PC boards that I ordered, they were only like $1 a piece. Okay, they were cheap. So total cost for one, okay, not including the entire cost that I paid for all the extra parts and everything, but just if you part out enough parts to put one together, come to $27.72. Okay, so you might as well round it up to 30. Time you add in tax to it, you might as well round it up to $30. So it basically cost me $30 to build one. So if I was to sell them, which I hadn't planned on doing, the time it took for doing all this and putting them together, it takes a little while to put one together. Not long, but it still takes a little while. It's a lot of soldering to do. So it takes a little bit of time to do a good job. I figured my time is worth 20 bucks. So 50 bucks, if anybody really needs one bad enough. 50 bucks. What do you think? Does that sound like a fair price? I don't even know. Probably nobody else needs one, so I'll probably have these to the end of time, but that's okay. If somebody pops up and needs one, then I can at least offer them a working one. So, whatever. Because I have an original, so I don't really need one. But I might keep one just for prosperity. I mean, it does have my logo on it. I put Sam's ARCADE FIX 2023 on it. And I did put the Hewlett Packard part number on it. So, there you go. All right. Well, what do you think of my project? Let me know in the comments. Am I crazy? Was I crazy to do this? I'm not going to tell you what I paid for this. How did I find it? Okay, on eBay, there were a person on there who was selling the complete kit. Okay, the box, the cards, everything, and they wanted like anywhere from like $500 to $800 for a complete set. Okay, which included this card. So, and they seemed like they were in the business of electronic equipment. So I sent them a message. I said, hey, do you have just the card? And do you want to sell it? And I didn't ask them how much they wanted for it. I said, I will give you X amount of dollars if you have one that works. So they immediately come back and said, sure, we'll sell it to you for that price. And I'm not going to tell you what I paid for it, but I probably paid twice of what one is worth. So you can kind of figure it out. But they sent me this, and it was in the original bag, and I could tell it was new old stock. It had never been put, you could tell the fingers had never wiped. Okay, where you plug it in, it had no wipe marks on it. So this was actually brand new old stock. So I'm happy with that, okay? I'm also happy that my comparator is working 100%, even though those 3 LEDs still bug me. So I might change those. I don't know yet. I might go with it for a while and see how it works. And if I have another LED fail, then I might go ahead and change all of them. So there you have it. Let me know what you think in the comments. If you like this, like, share. Be sure to subscribe to the channel. And hopefully before long we're going to be back with some repair videos. And maybe we'll get to use this thing finally. I have an asteroids board to fix. Actually, I got 2 asteroids boards I could fix. I might go ahead while I'm working on one. I might go ahead and fix the other one. I also have a Star Wars board I need to fix. And I got more. So stay tuned and be sure to subscribe so you'll be notified when I upload the next video. So hopefully we'll see you before long. So this has just been another Arcade Fix. Have you had your Arcade Fix today?